Yes, Nihal, go ahead. What is your point? Yes, Myra, you have raised your hand. Do you have any issue? Yes, Myra, go ahead. So, do you have any issue? Raise your hand.
Sir, yes, sir. I think were you speaking because I couldn't hear a single thing. So I thought even the class didn't start,
No, no,
and I
no.
was already 10 minutes late because of my I couldn't get into the class for
No,
some
no, no.
reason. My Google wasn't accessing, and it was like you're not letting me in.
No, you're completely fine. So I started actually the 6 minutes later. So because no one come actually, some of you come actually on time because some of guys actually they're coming up to. So every time I started in the 5 minutes later actually. So today I started in 12:36. So it was 6 minutes later. So all right. So I just asked them, do you have any issue or any question? And I also tell them we're going back to our in-person class. Actually, those the thing actually we are talking about here. You get the SMS, right?
Oh, sir. So basically, you didn't go through any lesson.
No, 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 no. I'm just talking with you
Oh.
because we are
Sir,
talking 1 week later, right? We talked in the last week, Wednesday. Monday was off, common holiday, so that's why we are talking with right now 1 week later.
sir, I have a question, sir.
Yeah, sure, go ahead.
স্যার আমাদের তো মানে অফলাইন হচ্ছে, সো আমাদের স্যার কুইজ গুলো কি স্যার আমাদের অফলাইনই হবে নাকি স্যার?
Yes, everything will be in person class. In the
ওকে স্যার।
online, that is in the in-person class means there will be nothing in the online. So, but the idea actually share with you, which is my personal idea. I do not know whether I will get that permission from the course coordinate. So, if he give me permission, I will definitely do that one, and it will help you a lot. Basically, in that case, actually, I can do lot of problem for you from different dimension or different level actually. So, which would be helpful if you want to do that.
ওকে স্যার।
স্যার
Yeah.
অফলাইনে কুইজ মানে কিভাবে নেয়, মানে ওইখানেও কি এরকম এমসিকিউ দিয়ে দেয়?
No, I said you there will be a lot of change actually in that case. I will say that when we will go back to the in-person class, there will be change, little bit change from this format. Probably there will be some multiple choice conceptual part as well as also problem solving part over there. Do you understand?
Yes, sir.
All right. So, is there any more question, or should we start? Fine. So, I'm going to start today's problem actually. It said that problem number one actually. Probably you guys know that there is a robotic club in the Brack University which is very active. They did a lot of competition actually. They in the back in 2012 or 13 probably they part in that NASA's competition, consecutive 2 year, and they did very well in that competition actually. So that's why this club is very active. When you come to the campus, you can join this club. So that's why I choose this point, this problem. I said that Brachio Robotic Club sends a robotic vehicle or the rover in Mars for exploring its surface in the collaboration with the NASA. The stationary Mars lander is the origin of the coordinate, and the rover is exploring the surface of the Mars in the XY plane according to this equation. This equation is given, where is x coordinate and the y coordinate will be vary according to this equation. Now they asked me to find out the rover's coordinate and the distance from the lander at t equal to 2 seconds. So that means after landing, 2 seconds later you have to find out what is his coordinate and the distance from landing point. Second one, find the rover displacement and the average velocity vector for the time interval t equal to 0 second to t equal to 2 second. Third one, find the expression for the rover's instantaneous velocity vector as a function of time. Fourth one, calculate the instantaneous velocity v in terms of magnitude and the direction at t equal to 3 seconds. And the fifth one, we have to calculate the acceleration of the rover at t equal to 3 seconds. These are the questions they asked me over here. Since it's a two-dimensional motion, I have to deal with that x and y coordinate at a time. So let's start for this one. So first one, I'm going to find out a rover coordinate. Since the equation is given me x equal 2 minus 0.25 t square, I just drop out that unit from this equation, and y equal to 1t plus 0.25 t cube. So y and the x coordinate will be vary according to this equation. Now I have to find out the coordinate. To find out the coordinate, I will just plug in the value of t into these two equations at t equal to 2 seconds, right? If I plug in, then x2, which is that coordinate at t2 times, so that's why I write down x2, that should be 2 minus 0.25 into 4. 0.25 into 4 would be 1, so 2 minus 1 is going to be give me the 1, and that y2 would be 2 into 1 minus 0.025 into 2 cube, which is the 8. So that will give you actually the 2.2. If you do some calculation over here, you can find out this thing. Now that should be the coordinate actually. So the coordinate, you can say that at t equal to 2 seconds, which is x2 y2, that numerical value would be 1 and 2.2. That's the coordinate. So this is one answer. So coordinate. Fine. Now I have to find out also the distance for this point from the landing. So when it's land, actually we consider that is actually the origin, and we start countdown from the time from there. So fine. So to find out that distance, basically I can express this vector, which is r2. I can write it would be 1 I hat plus 2.2 j hat, right, which would be the displacement at r equal to 2 seconds. Fine. Then I can find out the magnitude of this displacement, which is going to be, you know how to find out the magnitude of that one. That would be 1 square plus 2.2 square. That's going to give me 2.42 meters. So this is the answer, which is the distance, scalar quantity. Fine. Now we are going to find out the rover displacement and the average velocity vector in between time interval 0 to 2 seconds. Alright, so now I'm going to find out displacement. Displacement we define, that was actually that x2 minus x1. Instead of x1, I'm going to write down x0, because I'm going to find out that displacement in between time t equal to 0 second to t equal to 2 second, I hat plus y2 minus y0 j hat, which is the two-dimensional case, right? So that's when I have to know this coordinate. I already find out x2 y2, which was 1 and 2.2, right? Now what about x0? If you plug in that t equal to 0 second into this equation, it would be the 2, and into the y equation, if you plug in the t equal to 0 second, y would be the 0. So that's mean x0 would be 2 and y0 would be the 0, right? I just plug in the value of t1, t2 and t0. Then I can find out this displacement, which is be x2 actually 1 minus 2 I hat plus y2 actually 2.2 minus 0 into j hat. Fine. Then we can find out. So if you solve it, it's going to be the I hat plus 2.2 z hat. So that will be the displacement of that one. So this is first one. And to find out the average velocity, average velocity, we'll use the general equation, which is we define del r divided by del t. So del r basically the change of position. For the two-dimensional case, we can write that would be del x divided by del t I hat plus del y divided by del t j hat, right? Then del x actually x2 minus x naught over here, and this would be t2 minus t naught I hat plus it would be y2 minus y naught divided by t2 minus t naught j hat, right? Now I'm going to just plug in that value so then we can find out these average values.
Sir, could you go through the average velocity, the first line again?
Yeah, first
The
line,
v
that,
equals to delta.
yeah, that's a general definition of the average velocity, right?
Yeah, so you started describing it, right?
Yes. So del r over del t. Then del r, which is the displacement. So since it's a two-dimensional, I separate them. Del x over del t I hat, this is the x component, and plus del y over del t into j hat, which is the y component. And del x actually the change, because I'm going to find out that average velocity in between time t equal to 0 second to t equal to 2 second. So that's why I write down x2, which is the displacement, and t equal to 2 second, minus x naught, which is actually the displacement, and t equal to 0 second, and divided by the time t2 minus t naught. Same thing for y component. You understand right now?
Yes, sir.
Alright, so now just plug in that value of this x2 x naught, y2 y naught, which is I already did for that case, so you can write. So basically the del this is actually the del r, which is the displacement here. So x2 was what? X2 was 1, right? And x naught was 2 divided by 2 minus 0 into I hat plus y2 was 2.2, y naught is 0 divided by 2 minus 0 into j hat. I just plug in the value of look at this is x2 1, x naught 2, y2 2.2, and y naught actually the 0. I just plug in that value over here. Now this v is become actually is going to be minus 0.5 I hat, right? Because 1 minus 2 is the minus 1 divided by 2, that's going to be the half. I'll find out minus 0.5 I hat plus is going to be 1.1 j hat. So this is will be your average velocity. This is a general formula to find out that average velocity, but there is one more formula actually you guys use, which is v equal to v1 plus v2 divided by 2. Remember, this formula is only applicable when the particle or the system is moving at a constant acceleration. Then you can use this equation, otherwise not. Or the constant velocity, if the particle moves at a constant velocity or constant acceleration, then you can use this equation, otherwise not. But this formula I can use whether the particle moves at a constant velocity or constant acceleration, or neither not. I can always use this equation. So that's why I will always this equation to find out that constant velocity. Can anyone say me that is this rover is moving at a constant velocity or constant acceleration?
constant acceleration.
Constant acceleration.
Oh, না y এ তো t cube আছে সরি স্যার না
Then what would be your comment?
So I think no sir, no constant acceleration or not velocity.
Yes, neither constant velocity not constant acceleration. It's a variable acceleration actually. It's moving at a variable acceleration, because if you take the second time derivative, your x component would be independent of the t, but the y component would be dependent on t, right? Because there is a t cube in y part. As a result, your y component will be the change, so the total acceleration will be the change, since the y component is changing. So that's why I can say that the particle is not moving, or the rover is not moving at a constant acceleration at all. So but look at this, I use this formula to find out that average velocity. This formula is going to always work. You cannot use this formula to find out that average velocity in this case, because the particle or the rover is not moving at a constant acceleration at all. So that's why this average velocity would be different. Fine. So if they ask you to find out the magnitude and the direction, you can find out what will be that. You know how to find out the magnitude of a vector, right? This vector is going to be 1.21 meter per second, and the angle is going to be, it will be minus 65.55, which would be from negative x-axis clockwise, or 114.4 degree. That's the answer. If you write this minus 65.5, you have to mention from negative x-axis clockwise. Negative, I should write the total line. Otherwise, it should be from negative x-axis CC. CC means the clockwise, or CW you can write up. Sorry, it should be CW. If it is counterclockwise, then you can write down CCW, counterclockwise. You have to precisely mention in that way, otherwise it will be wrong. Alright, so this is question about the B. Now I am going to find out that instantaneous velocity as a function of time. Fine, so this is number C. To find out the instantaneous velocity, we define the instantaneous velocity V actually del dr over dt, right? This is the general case. So since it's a two-dimensional, I can write it will be dx over dt I hat plus dy over dt into j hat, right? I can write this one in that form.
Yes, sir.
Now my x coordinate is given, which was 2 minus 0.25 t square. If I take that first term derivative of this equation, dx over dt, that's going to be 0 minus 0.5 t, right? Am I right? What am I writing over here?
Yes. Yes, sir.
So for the y coordinate, it would be 1 into t plus 0.025 t cube. So if I take that first term derivative, I will find dy over dt. That's going to be is a 1 plus, which would be 0.025 3t square. So 0.025 into 3, it's going to be the 0.075 t square, right?
Yes, sir.
That's the total
Yes.
equation. So you can write in that case that V is going to be x component, I will write minus 0.5 t I hat plus it would be 1 plus 0.075 t square into j hat. This will be velocity at any time of this rover, which is also the t dependent, right? If you plug in the t at different time, the velocity will be different. So that's why this rover is not moving at a constant velocity. From here you can say that one. So this is the answer number 3. Now question number 4, they ask you find the instantaneous velocity at t equal to 3 seconds. So I'll just plug in the t equal to 3 into this equation, which I can write that velocity at t equal to 3 seconds. I can write that's with the v3. If you plug in, it's going to be that minus 1.5 I hat plus it would be 1.675 j hat. So that would be the velocity. They are asking me to find out the magnitude and the direction. I have to find out over here. Unless they ask to find out the magnitude and direction, you can keep it in that way. So in this question, they asked me to find out the magnitude, right? So
Sir, could you scroll up a bit?
Sure.
Sir, I too. Just want to see the first part.
Is that okay? Or should I do more?
Yes, sir. Now it's okay. You can go back.
Okay. So if you find
Thank
out a magnitude of this vector, that's going to be the 2.25 meter per second, and the angle would be minus 48.15 degree. same thing from negative x-axis clockwise, or you have to write 131.85 degree. So this is will be the answer of this question number 4. Now in the question number 5, they asked me to find out the acceleration of the rover at t equal to 3 seconds. Fine. To find out that acceleration, we'll write this equation, the first time derivative of the velocity function d over dt, right, or the second time derivative of the position function d square x dt square I hat plus d square y divided by dt square j hat. So it will be easier for me to take the first time derivative of this velocity function, right, instead of take the second time derivative. So if I do that, then this will be minus 0.5 I hat.
So if someone wants to do it with the first one,
Sorry, I didn't get you.
so you're talking about the second derivative, right?
The first time derivative of the velocity function, because I'm going to find out the acceleration,
Yes, sir.
right? So I'm going to take that first time derivative of the velocity function, because so I already find out that velocity, which is this equation, this one. So I can take the first time derivative of this equation or the second time derivative of this x or y function, whatever you like, you can do that. But it would be easier for me to do that one. Whichever you like, you can do by yourself. It's not a big deal, but do not make a mistake doing that one. That would be my point. So if I do that, I'll find out minus 0.5 I hat plus, I'm doing that for velocity function first time derivative, 0, there is a 1, plus 0.075 into 2t into j hat. I just take the first time derivative of this equation, this one. Fine, then it will be give me a would be minus 0.5 I hat plus 0.075 into 2, that's going to be that 0.15 into t into j hat. So this is would be actually that acceleration equation. Now you can see that this acceleration is dependent on t, which is actually that as a function of t over here. Now if you plug in at t equal to 3 seconds, you will find out that acceleration at 3, which would be minus 0.5 I hat plus is going to be 0.45 j hat. So that would be actually your acceleration of that rover at t equal to 3 seconds. If they ask you find out the magnitude and direction, I hope you can do that, right? You know how to find out the magnitude and direction of a vector. That would be 0.67 meter per second square, and the theta would be minus 41.98 degree, which is again from negative x-axis clockwise, or you can write 138 point, sorry, it's a point, 138.01 degree. So that would be your answer. This is the answer of question number 5. All right, let's go for the next one. Next one is another game. Actually, we are considering, say, in a football match. Actually, two player, one player actually the Lionel Messi kick off the ball into the air with a velocity 25 meter per second, making an angle of 30 degree with the ground. After a certain time, the ball was received by the Neymar at the ground level. So the scenario is like that. Say that one player kicked the ball from the ground, and it after a certain time that another player received the ball also at the ground level. And they also said that neglect the air resistance for this following calculation. So first question they ask, how long does the ball take to reach its maximum height, and we have to also calculate that maximum height. That's fine. So I know when it would be at the maximum height is vertical component of the velocity would be the 0, right? We'll use that idea. I'm not going to write down, although this is an ideal situation, but I'm not going to use that special case equation. I'll do in general way. So in that case, the Vy would be 0. That's fine. So Vy is basically V naught sine theta minus gt would be equal to the 0, right? So I use that formula, V equal to U plus AT, but in from the y direction. Then we can find out that t, which would be V naught sine theta divided by g. And V naught sine theta, I know V is basically the 25, and it makes an angle 30 degree. This is actually 25 meter per second. This makes an angle 30 degree. Sorry, this will be 30 degree. And then just plug in that value, which would be 25 into sine 30 divided by 9.8. Then it would be t would be it's become 1.27 second. 1.27 seconds. So at that time the ball will be reached at the maximum height. Now, what will be the velocity if I ask you at the maximum point of the ball? If I ask you what is the velocity of the ball at the maximum height?
Sir, what is the question, sir?
What is the velocity of the ball at the maximum height?
0.
0, sir.
0?
Vx. No.
Vx.
0? Y component is 0. It
Sir,
doesn't mean that
but
the total
Vy is 0.
yeah,
Yes, sir.
Vy is 0, because the total velocity in that case, if you write Vx I hat plus Vy j hat, this Vy is going to be 0, but Vx is not 0, right? So the
Yes,
total
sir.
velocity would be the Vx. So Vx actually the V naught x I hat. It's not the total velocity 0 over here. Total velocity could be 0 if you just throw the vertically upward at the top point, then the velocity will be the 0 for this case, this scenario, when you throw something vertically upward. But when you say makes a trajectory like that projectile, actually in that trajectory, so total velocity is not 0 at the top point. We discussed those things. Alright, so that's a different issue. That's not a part of this question. Fine. Now I'm going to find out that displacement, which is vertical displacement, because they also asked me to calculate this maximum height, which is, I would say, the vertical displacement is y. So I can use two equation. I'll use this vertical displacement, which is my famous equation, y equal to y naught v naught yt plus half of ayt square. Another, you can use that vy square equal to v naught y square minus 2gy. So I will use this one. So you can use that one also, check whether it is going to be the right or wrong. So fine. So if you do that, then this one is going to be the 0. Y, I will find v naught y, actually the v naught sine theta, right? V naught sine theta into t minus 4.9. G is minus 9.8 divided by 2 is t square. I know the time, which is actually that 1.27 second. If you plug in v naught, actually 25 into sine 30 into 1.27 second minus 4.9 into 1.27 second square. So if you solve this one, then you will find out that y would be 7.97 meter. So that would be the vertical displacement, or that would be the maximum height of this ball. So this is the answer of question number A. Now the second question, they asked me, find the velocity of the ball at t equal to 1.5 second after the kickoff. So after the kickoff, you have to find out the velocity of the ball 1.5 second later. Fine. So the velocity of the ball, I can write it be Vx I hat plus Vy j hat, which is the total velocity. Vx will be remain same, I know that, right, which would be v naught x. That would be v naught cos theta, which is 25, sorry, cos 30, which would be 21 something, probably 21.65 meter per second. That is the Vx. Yes, is there any question?
স্যার ম্যাক্সিমাম হাইট বের করতে হলে ওইখানে কি ভিওয়াই 0 হবে না?
Vy total velocity is not 0. Vertical component is 0. Total velocity is not 0 at the maximum point for this case. Are you
স্যার
present? Yeah, go ahead.
only use for VY component, so I think স্যার এখানে VY কম্পোনেন্টটা ইউজ করা হয়েছে না জাস্ট,
Yes.
তাহলে ওইখানে কি 0 হওয়ার কথা না? ওই যে ভিওয়াইটি এই যে এই ইকুয়েশনটাতে।
This one.
জি স্যার।
So what is V not Y?
এটা তো ওই ওয়াই অ্যাক্সিস বরাবর এই যে ভি এর কম্পোনেন্ট।
It's the initial component or final component?
ও ইনিশিয়াল, সরি স্যার।
Yes. Look at the equation. And you're talking about the final component. You're talking about the Vy, which is the final component.
ও আচ্ছা স্যার, আমি ভাবছি যেই পয়েন্টটা বের করতে হবে ওই পয়েন্টে কত ভিওয়াই হয় ওইটা ইউজ করতে হবে।
No. Then you have to understand the equation.
জি স্যার, থ্যাংক ইউ।
All right. So fine. Now look at this. This one I'm going to use. So now I'm going to find out the Vy would be V naught Y plus AYT. So this is the final velocity and this is the initial velocity, which is exactly V equal to U plus AT formula, where you say that U actually the initial velocity. Instead of U, I'm saying that V naught Y is my initial velocity. So fine. So V naught Y actually V naught sine theta minus GT. I'm going to find out that velocity at t equal to 1.5 second, right? I'll plug in that one, that V actually 25 into sine 30 minus 9.8 into t equal to 1.5. So if you do that, sorry, it's a Vy. So Vy in that case would become minus 2.2 meter per second. Right, so this is the Vy component, and it's minus, definitely it crossed the maximum height because I'm going to find out the velocity at t equal to 1.5 second, but I find out that ball reached the maximum height at t equal to 1.27 second. So that's mean at 1.5 second definitely it will cross the maximum height. That's why this Y component become negative. Once that particle cross the maximum height is vertical component, that means Y component would be negative towards the downward direction. That's why I can say that total velocity would be Vx I hat plus Vy j hat. So Vx I find out 21.65 I hat minus 2.2 j hat. You can write down the meter per second. So that would be that velocity. So if you want to find out the magnitude, that magnitude would be 21.76 meter per second, and its angle would be minus 5.80 degree. Now I don't have to use them from negative. This minus 5.80 degree from positive x-axis. You can draw that one because your x component is positive and the y component is negative. Then definitely the resultant velocity will be in between these two one, which is this is your Vx and this is your Vy. Then if you use tan inverse y by x, that would be your angle from x to y, nearest x to y direction. So that's why this would be angle, and this angle would be clockwise direction. So that's why it's a negative, which is actually minus 5.8 degree. I don't have to mention that one because it is from positive x-axis clockwise. Fine. Now the third question, how far was Neymar from Messi, which is basically that horizontal displacement they're asking over here, or you can say right now it for this case it will be basically the range, right? So this is actually the distance between them. I'm going to find out that distance. So I would write this x would be v naught cos theta into t. Now what is this t over here? This t actually the total flight of time, right? So starting from that point is come back over here. In that case is vertical displacement is 0 for this case. So which would be I can write, because we find out the time t up in the previous case, and this t would be basically the 2t up. Initially I find out the time to reach at the maximum height. So if I make that double, I can find out this is the total flight of time. I just plug in into that. So V naught actually 25 cos 30 degree into 2 into 1.27 second, right? Because T up was 1.27 second. That's I find out time to take to reach at the maximum height. I make it double because it's a symmetric and it's an ideal situation. So that's why I make it double over here. If it's not symmetric, then I have to find out. So the ball, if the ball player, say the Neymar received the ball from here, from some vertical height, then you cannot use this equation. You have to find out this time. What would be that time over here? Fine. Now if you solve this one, then you will give you that will give you actually 54.99 meter. So that should be that distance between these two players. Do you understand?
Yes, sir.
Alright, so now that fourth question, draw the displacement versus time graph for the motion of the ball. Can anyone tell me what would be that? Or just
Sir, could you repeat the question?
what would be the displacement versus time graph for the motion of the ball? This is my time, and say this is actually the displacement I write on the R. Displacement versus time graph of the motion of the ball. So it is basically
So it would be like a
trajectory,
parabola.
Parabola,
Yes, sir, like
exactly.
you're right.
Yes, sir.
Parabola of this ball. Right, so every single point actually indicating the displacement of this ball with respect to time. Alright, next go for the next one. So in this case, basically a tennis player actually they're serving the ball. So he's serving the ball from 2.5 meter above, and his net is 15 meter away from him, and the net is 0.5 meter height. The height of the net is actually. Now in the first question they ask you what would be the minimum speed is required. What is the minimum speed is required for the ball to clear the 0.9 meter high net above the 50 meter from the server. If the ball is launched from a height of 2.5 meter, so that means what will be the minimum speed so that ball just clear the net, which is height is actually 0.9 meter. So that would be the minimum speed. If the speed is minimum, then the ball is not going to be that cross the net. It will be strike the net actually. That's mean actually they clear the net. If you serve more than that, definitely it's going to be that overcome that barrier of net. So they asked me to find out this minimum speed, and the question B, where will the ball land if it just clear the net, and how long will it be in air? So if it's clear the net actually. Fine. So my idea to solve this question, basically I know when this player serve the ball, if I choose say this is my reference x-axis and this is my reference y-axis, I know that ball speed is totally towards that horizontally initially, right? When a tennis player actually serve the ball, they serve in that way actually. There is a reason. We will talk about this thing when we're going to talk about the momentum case. The same problem I can discuss the momentum issue actually. This is the application of this thing actually, real life case. Fine. I have to actually find out at what time basically it will travel that distance. I'm going to find out that time first. So when it's going to be the cross this 0.9 meter height, at that time the ball must be travel also this horizontal displacement, which is 15 meter, this one.
right? If the ball want to cross that 0.9 meter, at the same time ball must be travel 15 meter along the horizontal direction. It has to be, otherwise it cannot cross that net. In that case, that's mean I need that velocity. I know along to the horizontal direction it will move at a constant velocity, which is v naught x into t. That will be the speed. I'm going to find out. I know that x, which is 15 meter. I have to find out that time. So that's mean at what moment the ball will cross this or travel this 0.9 meter vertical displacement, because it is start from 2.5 meter high, and what time it will cross this vertical displacement 0.9 meter from the surface of the earth. Fine. To find out that time, actually I'm going to use this equation. Y would be y naught v naught yt plus half of a yt square. Now if I choose say that that's my origin, this is the origin, I'm sorry, or I should choose the origin from ground. Let's choose the origin from the ground of the ball. It will be the minus if you choose that over here. Actually, it's not a big deal. So fine, then I can write it start from 2.5 meter high, is going to be the cross 0.9 meter, and when it start, what will be that initial velocity?
Sir, v naught y is 0 when it's start.
Yeah, exactly. That's the point. That's the main point of this equation. If you can understand, that's great. So v naught y must be the 0, because I'm the player serving the ball towards the horizontal direction. So that's mean total velocity basically that completely horizontal velocity. It has no vertical component of the velocity, right? So that's why v naught y would be the 0 minus 4.9 t square. Then I can find out that t from there. So if you solve, because it's going to be that 4.9 t square equal to 2.5 minus 0.9. I hope you can find out the t from there. If you do, so this is going to be 2.5 minus 0.9, so divided by 4.9, that will give you actually 0.57 second. So that's mean after serving with that some minimum speed, 0.5 second later the ball is going to cross that height 0.9 meter starting from 2.5 meter.
স্যার
Yep.
স্যার যদি আমরা অরিজিনটা ওই লোকটার হাতের ওইখানে ধরি, ও তখন এই ইকুয়েশনটাতে কিভাবে মান বসাবো?
In that case, this would be negative, this would be also negative.
স্যার ওইটা একটু দেখাই দিবেন।
The same thing I said you, plug in that this would be negative.
স্যার ওয়াই নট কি তখন 0 হবে না?
Why?
কেন অরিজিন থেকে তো
Why not would be negative?
okay.
It has to travel this 2.5 meter also.
স্যার তাহলে ওয়াই নট কখন 0 হয়?
Oh, you are talking about that. Oh yes, in that case y naught is 0, but that displacement in that case is travel basically y minus y naught distance, right? So that's mean basically you have to subtract this one in that case 0.9. You have to subtract 2.5 minus 0.9, because basically it's traveling that distance, right? So this is the 0.9. If you say this is actually the 0.9, I'm dealing with only that distance, which is 2.5 minus 0.9.
Oh, okay, sir.
Right, that's to be the case actually. Alright, so I find out that time. Now I'm going to find out that velocity, which would be x into v naught x into t. I'm going to find out that v naught x from there, it will be x divided by t. X is 15 meter. I know that it will travel at that time. It will travel this 15 meter divided by t. I find out which is 0.57. Then this v naught x would be 26.3 meter per second. So that would be the minimum speed. So if the player serves the ball with 26.3 meter per second, then the ball will just cross the net, which means it will clear the net. If it is less than that, then definitely the ball is going to be strike the net. This is the answer of this first question. Fine. Second one, where will the ball land if it just clear the net? So that's mean I have to find out starting from that distance where it will strike over here. Although the drawing is not exact, they try to show that one. The drawing saying that it is just striking that point, which is not exact drawing over here. Fine. So that's mean I can use the same equation to find out that distance. I will use x equal to v naught xt. I know that v naught x, which is 26.3. I'm going to find out right now x, right? Because I serve the ball at 2.5 meter high with a v naught, and it's going to be strike the ground. And how much time would be for this case, the time of flight? If I can find out that time of flight, then I'll be able to find out this horizontal displacement, right? Okay, now find out the time. Now if I find out that time, I'm going to again use this formula, y equal to y naught v naught yt plus half of ayt square. Excuse me guys, my physical condition was not too good because last Saturday I took the third booster dose, which is the third vaccine. So physically still I am not totally fit. Alright, so fine. So if the case is that, then I should write this y would be 0, right? Y naught would be 2.5 and v naught y is again 0 basically, and this is 4.9 t square, right? Can I write in that way? You understand this?
Yes, sir.
Alright, so then you can find out basically that t would be 2.5 divided by 4.9 square root, which is going to be 0.714 second, which would be actually basically the time of flight of this ball, which they asked me in the third question actually, how long it will be in the air. So that will be the case. Alright, now I can find out this one again. I'm going to find out that displacement at that time, which is v naught x into t. V naught x actually 26.3, because that was the minimum speed. It was served the ball by the player into 0.714. If you do that, then this x would be 18.8 meter. That would be that case. So that's mean it will be land. This is actually 15 meter. From that it would be somewhere over here, which is 3.8 meter, because 15 plus 3.8 is going to be 18.8 meter. Fine, and the question number 3 you can find out, which is time of flight would be, you can write 0.714 second, which I did in that previous case, right? I can write down directly from this part.
Sir.
Yep.
স্যার এক্ষেত্রে তো হাইয়েস্ট পয়েন্ট হবে যেখান থেকে থ্রো করা হয়েছে ওইটা না?
Highest? No, don't. I cannot say that one. It would be the highest point over here basically. Technically,
Sorry, in horizontal component?
yeah, there would be that horizontal component, but I have to check that one. I'm not sure about that. It would be in the highest point where it started, although its velocity is basically that horizontal component over here, but you have to check that trajectory, whether it's going to the maximum point or not. You have to do the reverse calculation.
লাইক স্যার ওইটা একটু করে দেখাইলে ভালো হবে।
So your question is whether this point is going to the maximum height or not.
Yes, sir.
Alright, so then I have to know that velocity over here. Probably it could be basically uh, it could be, let's check that, because I have to do the reverse calculation over here, right? Fine, let's check that. So first, for that one I have to know the velocity over here, because at that velocity I'm going to throw that one in the opposite direction, right? And then I will check that whether this velocity will be if I throw in that way, whether the time of flight is going to be whatever it is. If the y component becomes 0 over there, then I can say that yeah, so it could be, but I'm not sure. I can make a guess actually. It could be, because basically we consider that the vertical component is 0 over here. It could be in that case, but I'm not sure about that. Yeah, so then find out that velocity. Did you understand my point, what I'm going to say?
Yes, sir.
So you have to do that reverse calculation actually. It would be, because why it would be, I'm saying that I'm not saying my answer, I'm trying to find out the answer from your side so that you can understand what I'm going to do over here. So I throw the ball from there and I'm going to find out that velocity over here. Then I'll do the backup calculation. So if I find out that the time, in that time actually basically that y component is 0, then I can say that they are definitely the start from is maximum point.
Yes,
Because
sir.
basically we know that from the theory part, right? If it is the maximum point, then definitely the y component must be the 0. Since we are considering that the y component is 0 over here, yeah, there is a possibility it could be the maximum height. It should be. Alright, so you have to find out Vx I hat plus Vy j hat. What will be the Vx? Vx is 26.3 meter per second, right?
Yes, sir.
What will be the Vy? So Vi would be V naught y plus Ayt. So we consider the Vy actually the 0 minus 9.8 into t was 0.714 second. Can you do the calculation for me, this one?
Sir, it's 6.9972.
Minus 6.99.
9972.
It's close to the 7 actually. Alright, so meter per second. That's great. So then the total velocity actually 26.3 I hat minus 6.99 j hat. Right. Now can you find out the magnitude and the angle of this vector?
Sir, magnitude আসছে 27.213.
Is the calculation is right? Because I'm not doing, you are doing, guys. Let's verify that one. 26 point?
Yes. So 27.21.
If the answer is not going to match, then responsibility will be your, because I'm showing the way. 26
So
point?
27. So 27.21.
7.1.
All right. 27.21.
21.
Yeah, meter per second. What about the angle?
Sir, it's 14.88.
14.88.
Minus 14.88.
Minus 14.88.
Minus 14.88. Now look at this. This is your x component.
It's a clockwise.
Yeah, clockwise. This is actually your y component. Right. So this is actually your minus 14. But I have to reverse that one. If I reverse, in that case, angle would be this one. That's going to do the work. It's again the 14, right? 14.88.
Yes, sir.
Now this vector is going to be the reverse. It should be minus 26. I'm going to write down this one over here. Minus 26.3 I hat plus 6.99 j hat. That would be that vector over here. I just flip the direction of that vector to showing you that. Now do that, your ideal case actually. So I throw that magnitude will be the same, right?
Yes, sir.
27.21. This is the magnitude, and this is my angle, which is 14.8 or 88. Right. Now check that. What would be its maximum height? To reach its maximum height, it would be.
আমারই তো ডাক দেবে না
Hello. Why are you talking, guys?
এবার আমি কি বলবো জানো আর না
Omar, turn off your mic.
Where are you, Omar?
স্যার আমি ব্যাংক নাও স্যার
What? What are you doing over there?
স্যার doing some my father's work
Oh. Then what is your father is doing? You are doing your father's job?
kind of sir
Kind of. Then you told your father, do your job. To do your job.
yes I'm doing both jobs sir
At the same time, you do the both job.
yes sir
You are superhuman.
Responsible so much.
All right, let's check
Sorry,
that.
sir, for that.
Please silent yourself. Fine. So now I'm going to check that one. So I'm going to find out just time. So if I find out my time of flight actually 0.7, what is that? 714. That definitely is going to be basically it will be start from that maximum height. Plug in that value, sine theta divided by g. If this one I find considering that VY is actually the 0, right? Let's check that. 27.21 sine
Sir, 0.713.
0.713 is so close to that one, yeah. The total
Yes, sir.
value?
No, sir, time, sir, time.
Or time? Yeah, it should be. Which is
Sir, I think, sir, 6.99 এর জায়গায় 7 নিলেই মনে হয় স্যার 0.714 আইসা পড়তো।
yeah, I say exactly. The 7.13 is close to 7.14 actually. It's not a big deal. After decimal point, you can consider the 2 point. Yeah, it should
Yes.
be definitely. It will be start from its maximum height. If you want to check that, because ideally it was because I didn't say that answer. Why? Because already I am considering that it is that vertical component is 0. It means that it definitely start from its maximum point. Do you understand? Who asked this question? What is your name? Who is that?
Sir, Okita.
Orpida. Good, very good, Orpida. Do you understand this right now?
Yes, sir. Thank you.
Yeah, technically it was because I know the answer, but I didn't say that one because I want to show you that, guys. I want to boost up your confidence so that we can go back to the back calculation. Whatever he did, definitely that's going to say. It should be talk with me. It should be. That's the science, guys. Unless it is do not talk with me in real case, then it's a garbage. Throw into the dustbin. I don't care about it at all. All right, thank you very much, Orpita. All right, so there is one more problem actually. I select it from your reference book, which is Raising Helido Worker. I hope you can guys do this one by yourself. It's from your you will find out this problem in your reference book, Raising Helido Worker, in the projectile motion chapter actually. I hope you can solve by yourself this one. So I'm going to solve another problem for you. Although I do not write down for you, but say that scenario is like that. There is a oh god. There is a farmhouse. I'm just going to draw one side of this farmhouse. So this is a farmhouse. One side I'm drawing. It makes an angle over here which is 40 degree, and a person is basically standing over here, which is say that 4 meter away from this farmhouse, and the height of this case actually it was 14 meter. A ball actually running downward into that roof in that direction. Over here, definitely the ball is going to be that it has a purely rolling motion, but we are neglecting the rotational part over here because we didn't introduce that idea. But in reality, definitely there will be rotational motion as well as translational motion. But we will only consider over here translational motion because since we didn't introduce the idea of the rolling motion. So when it's fall of that surface, say that the velocity of this one is 7 meter per second. And the trajectory of ball would be over here. I do not know whether it can hit that person head, whether it can drop it over here. So the question they ask you, where will the ball hit, whether it will hit the person head or whether it will strike the ground. And if it strike the ground or head, at what velocity it will strike. Fine. To solve this problem, basically I am going to consider, say this should be component of the velocity, this should be your vx, I should write the v naught x, and this should be your v naught y, right? Say if it is strike the ground, then it has to travel this vertical 14 meter, and there is one more information actually. The height of this person actually almost 1.9 meter probably. Yeah, it's a tall man. 1.9 meter. He's bigger than me. I'm 1.72. All right, so let's I consider actually it's travel this 14 meter vertical displacement. Then how much time it will take when it's going to be strike the ground. If it is so strike, I'm going to find out that time, how much time it will take to travel this 14 meter, and in that time I can also find out what would be its vertical displacement. In that time is horizontal displacement. If the horizontal displacement is equal to the 4, because if whatever the time is taking to travel this 14 meter in the vertical direction, it will also exactly travel at the same time in horizontal direction. Not the 14 meter, it could be different, right? So if somehow I can find out at that time it also travels this 4 meter along to the horizontal direction using that equation, which is x equal to v naught xt, then I can say that the ball is going to strike the person head, right? Or vice versa, I can find out the time. In different way you can do that. Basically, I know this x, I know this v naught x also. V naught x is v naught cos theta, which would be 7 cos 40 degree, right? And v naught y would be v naught sin theta, which would be 7 sin 40 degree. Am I right? That's fine. So instead of considering this one, actually first I'm going to find out this vertical displacement. If it is travel this total distance 14 meter, what time it will take. So I can write this y equal to y naught v naught yt plus half of a yt square. This is my equation. If you plug in, I'll write, so say right now I'm considering, say that origin is over here. Then I can write, so this is y would be minus 14 y naught is 0, v naught y is minus, because 7 sine 40 degree into t minus 4.9 into t square. Can you write this one? Is there any question over here? So it would be, if I is a plus, and this thing if you solve, this is going to be 4.49 t minus 14 equal to the 0. It's a quadratic equation. If you solve, you will find out the two value. I am taking the positive one, 1.29 second. That should be the time of flight if to travel this 14 meter in the vertical displacement. And in that time, I can find out that horizontal displacement. Actually, x would be v naught cos theta into t, and v naught actually is 7 cos 40 degree into 1.29. In that case, x would be 6.93 meter. Yeah, that's fine. So which is more than 4 meter, right? Fine. But I'm not sure about that. Well, it crossing that one, it just touched the person's head. I'm not sure about that, because this is there is a possibility, right? Just touching that person, that ball could be also moved that distance. So I can make a guess from there. There is a possibility that the ball is not going to strike the person's head, but I cannot sure about that. It could be just to touch the person's head. It could be, right? Fine.
Yes, sir.
To make that sure or certain, I need to check actually what is the vertical displacement at that time when it crossing that 4 meter. If I, so that means how much time it will take to take this 4 meter. In that time, what would be its vertical displacement? Because in that time, definitely it has to travel 14 minus 1.9, which is going to be 2. Is it 12.1 probably? Yeah, 12.1. In that time, if it is travel 12.9 meter, then I will say definitely it is going to be just touch the person's head. If that vertical displacement is less than that, then I will make sure that definitely the ball is not going to hit the person at all. I'll check that one right now. Fine. So let's do that. To travel.
Sir, sorry to interrupt you. So could you just slide a little bit over, right in the solution part,
Yeah.
a little bit? Yeah. Okay, sir.
All right. Now I'm going to find out how much time it will take to travel this 4 meter, which is v naught cos theta into t. I can find out the t from there. It should be 4 divided by 7 cos 40 degree, right? And that will give me 0.746 second. So that's mean to travel, it will take to travel 4 meter along to the horizontal direction, it will take 7.746 second. Now I'm going to find out what is vertical displacement in that 0.74 second. If it is equal to the 12.1, then I can say that it will just touch the person's head. If it is less than that, then definitely I can say that the ball is not going to strike the person's head at all. So fine, I can write y equal to y naught, v naught y is into t my plus half of ay. I'm sorry, I'm taking 2 minutes extra basically. I'm sorry. So you can write on this one. So this y naught would be 0. Then we can write this y would be v naught sine theta. It's going to be minus over here basically. V naught 7 sine 40 degree into, I'm going to plug in this 0.74 second minus 4.9 to t square. T is 0.746 square. So if you do that, you will find out that y is going to be the minus 6.42 meter. Minus 6.42 meter means from here actually. So this one actually, this length, because I choose that origin, so it's traveling this distance which is 6.9 meter. So it's not 6.9, 6.4 probably. Yeah, 6.42. Right. So that's mean this one actually the 14 to travel. The person height was 1.9, but when it's traveled this 4 meter along to the horizontal direction, its vertical displacement was 6.42. I use the minus sign, basically I choose this is origin. So that's why it's the minus sign. So that's mean when it's crossing that 4 meter, it was basically from the surface of the earth, you can say that, what would be that? 14 minus 6.242. 14 minus 6.42, which is 7.58 meter above, which is 7.5 meter above that person from the surface of the ground. So then I can say that definitely the ball is not going to strike the person head at all. Do you understand? Yeah, thank you very much guys. I'm done with for this week. Yeah, give your attendance. Go ahead. I didn't take that one.
Sir, how about our assignment, sir?